Hello, Math 8 students. Welcome to Unit 1, Lesson 5, Coordinate Moves. We're going to get started here. It says translating coordinates, and what you're going to do is look at image T and image U. And we need to select all of the translations listed that take triangle T to triangle U. And it does give us a hint that there may be more than one correct answer. Here's your options. Which of those four options will take triangle T to triangle U? Porter. Number 1, how do you know? Good. -3, 0 is in the same spot as the point 1, 2. They both refer to the corresponding parts, right? Corresponding parts there. Okay. What else? Anna? Good. -4, -3 goes up to 0, -1. What about the other two? Do they work? Why not? Michaela? Yeah, on both of these, right? This one is going in the reverse direction. This is how we would go from U to T. But that's not what the instructions said, so we need to make sure that we're really being careful with that. Now, let's move on. We're going to talk about reflecting points on the coordinate plane. And it looks like I am going to have to shrink up my screen a little bit better so that we can see it all at once. Let me go over the directions so that you guys can get started on that. We have a list of points, and on the coordinate plane, I want you to plot each point and label with its coordinates. That means when I plot the point A at 0.5, 4, I'm going to label it 0.5, 4 so that I remember what it is. So please take a minute to get all of that done. Online learners, pause the video so that you can get that done too. When I resume the recording, this is going to be the right size so we can see on the screen all at once, and all of the points will be there. So online learners, be sure to pause the video. All right, we're back. I have my screen fixed so that we can see the directions and the entire grid all at the same time. The plots are pointed, so please, the plots are pointed. The points are plotted, so please check to make sure that you have your points plotted in the correct place by comparing your grid to my own. And now that we've plotted each one of them, the next set of directions here, it says using the x-axis as the line of reflection, plot the image of each point. So I'm going to make sure that we really understand what that mirror line is, and take a second to think about where each one of those reflections are going to be. Where is point C going to be if it's on this side of the mirror? Where is it going to be when it is reflected? Houston? On the positive side. So if it's on the negative side, it's going to be on the positive side. So we're always going to be putting our images on the opposite side of our mirror line. Go ahead and start getting those points on as well, and we'll talk about them as we do them. A, where is A going to be? Well, it's over halfway through, and I can see that it's 1, 2, 3, 4 steps away. Let me just highlight that here as I talk about it. 1, 2, 3, 4 steps away from the mirror. So we're going to see the reflection 1, 2, 3, 4 steps away from the mirror. And I'm going to call that one A prime. So I'm skipping ahead to D, right? Include a label using a letter. So A and the reflection is A prime. And I'm also going to do step C at the same time. I'm going to label it with its new coordinates. And the new coordinates are over 0.5, and this time it's down 4 for a -4. Continue on with each of those. Where is point B going to be? Who can give me the directions or tell me the coordinates of that new image for B? Oscar? -4, -4? There you go, -4, -5. I think you said it right the first time. B prime, and listing those coordinates, -4, -5. For those who are struggling, and I hope that there's not many of you, you can see that this point is 5 steps away, staring straight into the mirror. So the reflection is 5 steps away, staring in the mirror, just on the opposite side there. Let's move on to C. Where is C going to be? Give me the coordinates of point C, please, when it's reflected. Ashlyn? Yeah, -7, +2 now. So we're going to call that one C prime. Seven comma +2. And D, where is D going to be when it's reflected? Did I stump you with that one?
No.
Okay, Damon.
It's going to stay right there.
It's going to stay right there. And what I want you to imagine, right, is if you put your finger right up next to the mirror and you look for that finger's reflection, you can see that that fingertip is still touching the mirror on the other side of the reflection. So this is you touching that mirror, and of course your reflection is going to be touching it too. So D and D prime are the same point. D and D prime are the same point, 6, 0. And our last one, E, who can tell me where E is going to be when it is reflected over the x-axis? Great. Porter. 0, 3. 0, 3. So it is positive, and that is going to be E prime 0, 3. Okay, very well done. So now, based on what you observed there, I'm sure you saw some interesting patterns. If the point 13, 10 were reflected using the x-axis as the line of reflection, what would be the coordinates of the image? And then it asks, what about 13, -20 and 13, 570? Now this time you can't graph them, right? There's not a graph for you to look at and to compare your answers. So how are you going to answer this question? Let's discuss at your tables first before we come back together on the recording and share our responses on the recording. All right, starting with 13, 10. The point 13, 10 reflected over the x-axis. What is the coordinates of that point going to be, Paul?
That would be 13, -10.
And how did you know?
Because it would go down the same distance in the y-axis that it would go up reflected.
Good. What he said is it's going to go down the same distance that it was going up when it's reflected. So we can envision that this x-axis goes in this direction, and this point 13, 10 is going to be up here, so the reflection is going to be down below. So all we're doing is changing that y-coordinate. What was a +10 is now going to be -10 because it's down below. And what would we do about the point 13, -20? What is 13, -20 going to be? Should see a few more hands. Let's get a little bit more participation. Liam? 13, 20, exactly, 13, +20. So this is kind of the opposite. That's this point that's all the way down here, and so the reflection is going to be the same distance away, but up above on the other side. And 13, 570, 13, 570, where is that one going to be, Elise? 13, -570, again, same concept. This is way far up here, so the reflection is going to be the same distance just all the way down below. So it's pretty easy to identify and predict what those coordinates are going to be when it's a reflection over the x-axis, right? Now, let's apply that same thinking. What if I'm doing reflections over the y-axis? So step 4, part 4 here, says the point R has coordinates 3, 2. You can see that it's graphed, but without graphing the reflection just yet, I want you to predict what are the coordinates going to be when I do the reflection over the y-axis. Quiet think time as you write that down. All right, who's willing to share their prediction? What do you think? Let's go with Natalia. Predict that it's going to be 3, -2. That's a great prediction. Does anyone have any other different predictions? Okay, Jaron.
I think it would probably be -3,
-3, -2. Okay. Any other predictions? Tempe? -3, +2. All right, all great predictions. Tell me how you guys made these predictions, because I'm seeing it's the same numbers reused, just with positives and negatives kind of switched around. How did you make these predictions, Anna?
Well, if you're still like going through and doing the reflection across the y-axis, then you would have to, it would still be 3 over, it would just be on the negative side.
Okay.
It would still be 2 up positive.
Good. So you're observing what we saw before, that when we're doing the reflections, we're still the same distance away. That's why we're keeping the numbers 3 and 2, right? We're still the same distance away. It's just that we're on the other side, so we might have a negative where there were positives before. Great. Now let's actually do it. Part B, we've got the point 3, 2. Again, make sure you are paying attention. We are reflecting over the y-axis, which means that we're reflecting over this line right here, yeah? So, with that in mind, where is that reflection going to be? So the R is staring into the mirror, which is going this way now, 3 steps away. So the reflection is going to be 3 steps away. Let's follow the rest of the directions. It says let's label that as R prime. And the coordinates are -3, 2. Yep, -3, 2. Who was the one who predicted this one? Tempe. Who else predicted -3, 2? Okay, good. And those who did not, did we have a good learning experience from that? Okay. So, suppose you reflect a point using the y-axis as a line of reflection. How would you describe that image? So again, just summarize. We only did one problem, okay? But can you summarize what's happening when I reflect over the y-axis? Write it down first, have that quiet think time. That way online learners can write their response as well. Pause the video if you need more time to continue writing, and let's come back together, guys. What do you think? What's happening? How can we summarize what we're seeing? Morgan?
The grid is not symmetrical.
Yeah, the grid is symmetric. Very good. How do we use that to identify those coordinates? Uh-oh, my thing turned off. Hang on. All right, technical difficulties are over. How do we use the idea of symmetry to help us identify what the coordinates are going to be? How is it changing? Paul?
You can just look on, based on the same point on the other side of the grid,
Okay.
see where it is.
Same position, other side of the grid. Ashlyn?
You could say, but based on where you're reflecting, like whether it's against the y or x axis, that's the point that's going to change either negative or positive.
Okay, I want to make sure that we really have a good understanding of that. What Ashlyn said is, depending on which line we're reflecting over, whether it's the x-axis or the y-axis, that's what determines which coordinate is going to go positive or negative, right? Let's talk about that a little bit more. Paul?
Now is it will be like reflecting the x axis or the opposite axis is what changes. So the x axis is what changes when you're reflecting the y axis.
Okay. You use the word axis a lot, and I think you meant coordinate for some of that. So I'm going to kind of summarize what I think that you meant. Yeah. So when I'm reflecting over the y-axis, right, here is R, and R had the point, or the coordinates 3, 2. I reflected over the y-axis. What changed? Which coordinate changed here? Well, let's see. The y-coordinate stayed the same. So which is the one that changed? The x-coordinate. Interesting. So when I'm reflecting over the y-axis, the x-coordinate is the one that changed. And that's where you were misusing the word axis. I think you were meaning coordinate. Is that right, Paul? Yeah. And the x-coordinate changes how? Does it just randomly become a completely different number? What does it change to be? Morgan? Yep, exactly. It's the opposite of what it was before. So here it was positive, and so it changed to be negative. And we saw that same sort of behavior when we were reflecting over the x-axis, but it was a little bit different, and we'll summarize that here in just. So we're going to come back to our reflecting over the x-axis, where we saw that similar behavior. It was a little bit different, but it was similar to what we saw reflecting over the y-axis. And I want to summarize that here, back on our first page. So we saw C had the coordinates 7, -2, and the reflection was 7, 2. We saw that A was 0.5, 4, and the reflection was 0.5, -4. What's happening is I'm reflecting over the x-axis now instead of the y-axis. what's happening is I'm reflecting over the x-axis instead of the y-axis. I should see more hands than this. Thank you. Paul? Is the y-coordinate, right? Yes. When reflecting over the x-axis, it's the y-coordinate that changes, which I know might seem backwards, but if you actually visualize it, it makes sense, right? Because it's the y-coordinate that tells us how far up we are, and so when we reflect, it's going to tell us how far down we are. So when reflecting over the x-axis, the y-coordinate changes, and exactly how does it change again? Quarter to its opposite. Okay. And now we are ready to switch gears and continue on. Transformations of a segment. We're not going to continue talking about reflections. We're going to start looking at rotations. Apply each of the following transformations to segment AB. We start by rotating segment AB 90 degrees counterclockwise around center B. So here's the center that we're going to be using. That means we're spinning it around this point. And when I spin it around that point, I'm going to call the new point C. I'm not going to call it A prime. I'm going to call it C. Notice B isn't going to be changing because B is where I'm poking my finger through that tracing paper and spinning it around. I'm going to pause the video long enough for you guys to work on that. Online learners, I will give you some directions for how to use your applet. All right, and here is the applet for the online learners. You can see the first question says rotate AB around point B. So in-person students took their tracing paper and copied that, poked a hole through B, and then twisted it. You guys, all you have to do is just move the slider, and it will rotate it into that position. Check your answers. Does it look like it's supposed to? Check the coordinates of C. They should be 3, -2. And for the next one, we're taking that same segment AB, only this time I'm rotating around A. So now I'm poking that hole in the tracing paper through A and spinning it around 90 degrees counterclockwise. So it ends up here. Notice the coordinates of that point. The coordinates of D are 1, 7. Okay. Then we were also asked to rotate segment AB 90 degrees clockwise around 0, 0. And that is going to be labeled B or E and S, E and S. And I'm just going to show you the answer here. Again, this time we're still taking that same AB, but now we're poking a hole through the origin and rotating it, and now we can see ES here. Okay? So this is what all of those rotations altogether look like. Answer question 4 now. Compare the two 90-degree counterclockwise rotations of segment AB. That would be, let me highlight them for you. This one, that was a counterclockwise rotation of AB. This was a counterclockwise rotation of AB. And I want you to compare them. What's the same? What's different? Have that quick conversation now as you answer question 4. Online learners, same question. How are they the same or different looking at this image or the applet? How are they the same or different? What are some things that you noticed? It's about time to wrap up here. So what are some things that you noticed? Paul?
The angle they create is the same, the real angle.
Good. Both 90-degree angles.
They're the same length,
Same length.
and the position is different, and they have a different direction.
Different direction. Interesting, because we both rotated them counterclockwise, right? However, choosing different rotation points made them kind of look like they were in different places there. Yeah. Anna Marie.
I noticed that they're both touching the original line,
Both touching original line.
and then neither have the same theme, but they're going opposite ways.
Okay. Anything else? Logan. I'm not sure what you mean by that, if we just swap them. What does that mean? And what if I switch that, though? Am I just reflecting it? Is that what you mean by switching places? Am I reflecting it? Now, if I did reflection, depending on where that reflection line is, I'm seeing it a little bit different. So I'm not exactly sure what you're saying, but I do want to point something else out instead that I think will relate a little bit better. Morgan Fletcher. Do you see how here is DA? And since they're both 90-degree angles from that same piece, they're both the same length. Do you see how I can take that and just translate it into the new position? That's the only other thing that might be worth mentioning. But I want you to notice that although we can do these translations, these rotations, we're not going to see some of those same patterns with coordinates that we saw here. They're a little bit harder to see, and that's probably going to be something that you learn next year instead of this year. Let's summarize. It's time to wrap this all up. We can use coordinates to describe points and find patterns in the coordinates of the transformed points. We can describe a translation by expressing it as a sequence of horizontal and vertical translations. For example, segment AB is translated right 3 and down 2. Notice what happens to those coordinates as it's translated right 3. How much did that x-coordinate change as it translated right 3? 3. And how much did that x-coordinate change, or the y-coordinate change as it went down 2? Do you see that? So you can observe those changes in the coordinates. Reflecting a point across an axis changes the sign of one coordinate. For example, reflecting the point A, whose coordinates are 2, -1, across the x-axis changes the sign of the y-coordinate. We already observed that, and we wrote it in our summary. Making its image, the point A prime, whose coordinates are 2, +1 instead of -1. However, reflecting A across the y-axis changes the sign of the x-coordinate, making the point A double prime, is how I would say that, A double prime. The coordinates are -2, -1. Reflections across other lines are more complex to describe. So we're going to focus on those x and y reflection lines because they're easiest to describe. The others are a little bit more challenging. As I mentioned, we don't yet have the tools to describe rotations in terms of general, or of coordinates in general. It'll happen later, but we're just not quite there yet. However, take a look at this 90-degree rotation, rotated around the origin. Here's the coordinates 2, 3. Here it is rotated 90 degrees counterclockwise. Do you see some sort of similarities? Okay, so yeah, we're seeing something, but it's a little bit harder to describe, so we're going to work on that. Point A has coordinates 0, 0. Yeah, okay, this is all the things that I just mentioned, so we're good there. Your homework is happening after the cool down. I always forget about the cool down. Let's do the cool down first. Rotation or reflection. One of the triangles pictured is a rotation of triangle ABC. Blue triangle ABC is our original. That is our pre-image. One of them is a rotation, one is a reflection. Which one is the rotation? And find the center. Which one is the reflection? And find the line of reflection. In-person students are thinking and writing their response. Online learners are thinking and writing your response. All right, and which one is which? Part 5, we're looking for the rotation. Which one is the rotation? Waiting for a few more hands. Okay, Elise, which one is the rotation? The green one is the rotation. So if you're saying that the green one is the rotation, can you also tell me the center of rotation? What is the center of rotation, Ashlyn? Okay, interesting. So here's something that I want to point out. is that when we're rotating, this will kind of come back into this. When I rotated AB around A, and I rotated around A, did A change in position? No. So if I'm rotating around A, would A be changing position? No, but it did. So that means we didn't just spin it around A. What did we spin it around, Liam? Yeah, we spun it around the origin. The origin was that center of rotation. Because now, observe this. Do you see how A is one diagonal away? So the rotated A is one diagonal away. So green and the center was the origin. 0, 0. And that leaves us with red being our reflection. What is the line of reflection then? What line was used to be the mirror? Reckon. The x-axis was the line of reflection. And now we're to the homework. The homework for you in-person learners is the rest of that packet. Starts right below that. Online learners, you guys know what to do at this point. This is another one, though, where it's probably better to print it and just do the practice problems and then take an image of it, uploading that image. There's a lot to draw on there, so it's a little bit harder to do that. All right, that's it for today. Have a good one. We'll see you next time.